Hello ladies and gentlemen, today we're going to be having a quick look at the concept of the mole. What is a mole, how do we define it, and also how we can link moles to properties of a substance such as their mass and molar mass. So first things first, what is a mole? Now IUPAC have recently updated their definition of a mole to tell us that it's any amount of substance that contains 6.022 times 10 to the 23 elementary particles. And here we're using the term elementary particles as a coverall term for particles such as atoms, ions and molecules. But you could also be asked to work out amounts of electrons in moles, for example, and you can have a mole of anything. Now this number which we use to define a mole, 6.022 times 10 to the 23, is important. It's a constant and we give it the name Avogadro's constant after the Italian scientist who discovered it, so Avogadro's constant. And it's important to remember that a mole of anything contains an Avogadro's constant of things or elementary particles in chemistry. So 6.022 is the Avogadro's constant. And we can think of this a little bit like a dozen. We know that if we have a dozen of anything, well, that equals 12. So if we had a dozen elephants and a dozen loaves of bread, we know they're quite different, but a dozen means that there's 12 of them. If we have an Avogadro's constant of something, be that atoms of carbon or molecules of water or even elephants, that tells us that we have 6.022 times 10 to the 23 of that particular thing we're interested in. So, how can we link the mole to mass of a substance? Now, there's an equation we use, which is this one, which is N is equal to a lowercase m here over capital M here. And in this equation, N stands for the amount of moles, which we give the unit mole. The lowercase m here is the mass of the substance we're interested in, which is in grams. And the capital M here is the molar mass of a substance, which has the unit grams per mole. And the molar mass of a substance is that substance's relative formula or atomic mass expressed in grams. So that is the atomic mass, or the MR, expressed in grams. So for example, for water, we can calculate the MR of water as being 18, which means that its M would be 18 grams per mole. This will come in handy later on when we try and calculate amounts of moles in a substance. So if we look at this next stage, it's quite common that you could be asked to calculate an amount in moles. So if we were asked to calculate how many moles of carbon were present in 12 grams, we would use the formula above. So we're going to use N equals M over M. And we know, hopefully, that because M is equal to a relative mass expressed in grams, that the M for carbon, we can read off the periodic table, is 12 grams per mole. So if we substitute the mass and the formula mass into our equation, we should end up with N equals 12 divided by 12, which equals 1 mole. Now to take this further, we know that this means that we actually have 6.022 times 10 to the 23 carbon atoms in our sample, because we have 1 mole. So it will contain an Avogadro's constant of those particles. If we look at our next example here, which is 27 grams of water, we're going to follow the same procedure. First things first, we need to calculate the molar mass of water. So to do this, we're going to first of all calculate the relative forming mass of water, which is 1 for the hydrogen plus 1 for the other hydrogen plus 16, the relative atomic masses there. And the sum of those is 18. And if we turn this into molar mass, that is 18 grams per mole. So now we write our equation again, which is N equals M over capital N. And we substitute in our values. So 27 grams divided by 18 grams per mole will leave us with an overall amount of moles of 1.5. So in this particular instance, we have 1.5 moles of water. And if we wanted to take this further again, to work out the number of particles present, we would do 1.5 times 6.022 times 10 to the 23, which should give us 9.033 times 10 to the 23 molecules of H2O in our sample. So, in conclusion, we should now know that 1 mole is equal to 6.022 times 10 to the 23 elementary particles, which is an Avogadro's constant of particles. And Avogadro's constant is given the symbol Na. We should also know that we can calculate moles using the equation N is equal to M over M, where N is the amount in moles, the lowercase m here is the mass in grams, and the uppercase M is the molar mass in grams per mole. Hope this has been helpful. If you have any other questions about the mole, please feel free to leave questions in the comments.